Welcome to Grade 7 Mathematics. In this lesson, we'll explore sets and Venn diagrams, a clear way to group things together and to reason about how groups overlap. By the end, you'll describe sets, compare them, combine them, and count their members without ever counting anyone twice. Here is our plan for the lesson. We'll describe what a set is, then meet subsets and the empty set. We'll combine sets using union, intersection, difference, and complement. We'll picture all of this with Venn diagrams, use a formula to count the members of two sets, and finish by organizing real groups from everyday Rwandan life. Let's start with the idea itself. A set is a well-defined collection of distinct objects. Each object inside the set is called an element. We list the elements between curly braces, so the set A might be 2, 4, 6, and 8. When 4 belongs to that set, we say 4 is an element of A. Two rules keep a set tidy. The order of the elements does not matter, and no element is ever repeated. With a clear set in hand, we can ask how one set sits inside another. Sometimes a whole set fits inside another. Suppose A is 2, 4, 6, and 8, and B is just 2 and 4. Every element of B is also an element of A, so we say B is a subset of A. In the diagram, the circle for B sits completely inside the circle for A. Two special sets are worth remembering. The empty set, which contains nothing at all, is a subset of every set, and every set is a subset of itself. Now let's see what happens when two sets only partly overlap. There are 4 ways to combine sets, and each has a precise meaning. The union of A and B gathers every element that is in A or in B or in both. The intersection of A and B keeps only the elements that lie in both sets at once. The difference, a minus B, keeps the elements that are in A but not in B. And the complement of A is everything in the universal set that is not in A. The universal set is simply everything we are considering for the moment. These 4 ideas come alive once we draw them. A Venn diagram turns these operations into a picture. Each set is a circle, and the 2 circles overlap in the middle. Let A be 1, 3, 5, and 7, and let B be 5, 7, 8, and 9. The left-only part holds 1 and 3, which belong to A alone. The overlapping middle holds 5 and 7, the elements in both sets, so that is A intersection B. The right-only part holds 8 and 9, which belong to B alone. Everything inside the 2 circles together is A union B. Counting the picture leads us straight to a useful formula. When we count the members of a union, the overlap causes a trap. Imagine the number of elements in A is 17, and the number of elements in B is 14, and 5 elements lie in both sets. If we simply add 17 and 14, we count those 5 shared elements twice. So the counting formula says the number of elements in A union B equals the number in A plus the number in B minus the number in A intersection B. That gives 17 plus 14 minus 5, which is 26. We add the whole of both sets, then subtract the overlap once to undo the double count. Let's put the formula to work. In a class of 30 learners, 18 play football, 14 play volleyball, and 7 play both sports. The number who play at least one sport is the number in the union. That is 18 plus 14 minus 7, which is 25. Since the class has 30 learners, the number who play neither sport is 30 minus 25, which is 5. The overlap and the formula handle the whole class cleanly. Sets are not only for the classroom, they organize the world around us. Think of learners taking French and learners taking English. Some take both, and that overlap is the intersection. We can group the districts of the northern province, and separately the districts that border Lake Kivu. We can sort phones that use MTN mobile money and those that use Airtel, some using each service. Even a farmer's crops split into those grown in the dry season and those grown in the rainy season. Wherever things fall into overlapping groups, sets give us the language to count them. Before we practice, let's clear up the traps that catch most learners. First, the intersection means in both sets, while the union means in either set. Don't swap the two. Second, in the counting formula, subtract the overlap only once, not twice. Third, a set never repeats an element, so list anything that appears more than once a single time. And finally, the empty set is a set with no members. It is not the same as the number 0. Keep these in mind, and your set work will stay accurate. Here is a quick summary of the key ideas. A set is a collection of distinct elements written inside braces. B is a subset of A when every element of B also belongs to A. Union gathers elements in either set, while intersection keeps only those in both. The difference keeps what is in A but not in B, and the complement keeps what is not in A. In a Venn diagram, the overlap is the intersection, and the counting formula adds both sets, then subtracts the overlap once. Now let's check how much you remember with 3 quick questions. Here is the first question. If A is 1, 2, 3, and 4, and B is 3, 4, and 5, what is A intersection B? The intersection keeps only the elements that are in both sets. 3 and 4 appear in each, so A intersection B is the set containing 3 and 4. Question 2 uses the counting formula. The number of elements in A is 20, the number in B is 15, and 6 elements lie in both. Find the number of elements in A union B. Add the number in A and the number in B, then subtract the overlap once. 20 plus 15 is 35, minus 6 is 29. Last question, and it combines several ideas. Among 35 learners, 22 study mathematics, 18 study science, and 5 study neither subject. How many study both? Since 5 study neither, the number who study at least one is 35 minus 5, which is 30. By the counting formula, 22 plus 18 minus the overlap equals 30. So 40 minus 30 tells us that 10 learners study both subjects. Wonderful work. You can now describe sets, find subsets, combine sets with union and intersection, and count their members with the formula, all using a clear Venn diagram. Take a moment to try a few problems on your own. In Module 12, we'll build on these ideas to explore probability, where sets describe the outcomes of chance. I'll see you there.